So now that we have a good understanding of what multi-tenancy is and the different techniques we can use to apply them in our systems, let's kick things off by switching to our IDE, opening up our terminals and generating a new module named Data Source using the Nest CLI. Let's also generate a data source service that we will configure to be request scoped. This provider will represent a database or data source connection in a real-world application. And lastly, before we continue onwards, let's generate a new users resource that we will use for demonstration purposes throughout this lesson. With all that in place, let's navigate to the newly generated data source service class, and first, let's make sure to flag it as request scoped. Next, let's inject the request payload into our class constructor using the inject decorator. Note that for now, we'll just use unknown as the type, as this context payload will differ depending on whether this service class is registered as durable or not. Next, let's navigate to the data source module file and make sure that the data source service provider is exported from this module. With this module in place, let's navigate to the user service we generated a minute ago and inject the data source service provider there using the standard approach. Let's also make sure to console log this. We can debug it later on in our terminals. To make the data source service available in the context of users module, let's make sure we add the corresponding import. Perfect. With our application running in the background, let's open up our terminals and use curl to trigger get HTTP request to the /users endpoint. Next, let's switch to the other terminal window, and as we can see there, the data source service was logged to our console, containing the actual request object as a request context dependency. Great. So far, we made our data source service request scoped, and we also injected the request object through the constructor. But none of this was new yet. We learned about the request scope providers in the fundamentals course. So where do durable providers come into play here? Well, as we mentioned in the previous lesson, durable providers are similar to request scope providers as they're both dynamic. The difference is, request scope providers by default are instantiated per each request, while with durable providers, we can control under which conditions they become durable. In fact, durable providers are just a subtype of request scope providers with one essential difference. While request scope providers are tied to the request lifecycle, durable providers' lifecycle can be controlled and managed by us. Alright, so back to our task at hand, let's navigate to the data source provider again, and let's flag it as durable, passing the durable:true to our injectable decorator. Also, before we continue further, something to always keep in mind, custom providers can be durable as well. Alright, back to our task. Let's note that, similar to request scoped, durability bubbles up through the injection chain as well. That means if user service depends on data source service, which is flagged as durable, user service implicitly becomes durable too, unless durable is explicitly set to false for user service provider, which right now it is not. Alright, with our first durable provider in place, let's now configure the strategy for managing durable providers in our system. For this, let's create a new core folder, and inside of this folder, create a new file called aggregatebytenantstrategy.ts. Inside this file, let's kick things off by declaring a new aggregatebytenantContextID strategy class and make it implement the ContextID strategy interface. Our IDE should prompt us to auto-implement that interface, so let's go ahead and do it. Next, let's declare a new private property called tenants. This collection will hold tenant IDs and their associated context IDs. Note we learned about context ID in the Diving into DI subtrees lesson. This context ID represents our manually created DI subtree. As we're using Express in this course, let's also update the type of the request parameter to be request from Express package. Depending on what we want to accomplish, there are different strategies for associating requests with specific tenants. For example, the tenant ID could be encoded in the JWT payload, or we could have a proxy in front of our API that would attach the corresponding xTenantID header. Even simpler if the communication is internal, meaning between private services running in an internal cluster. In that case, we could just manually attach that header to every request when calling another service. In this lesson, we'll be aggregating requests by xTenantID header values, but note that the implementation won't differ much depending on which approach you end up taking. Alright, so back to our task. Let's start by retrieving that xTenantID value from the header, and if it's undefined, let's just return the original context ID object. Next, let's declare a new local tenant subtree ID variable that will represent our context ID object for the given tenant DI subtree and check if our collection already has such a key. If so, let's retrieve that value and assign it to the tenant subtree ID variable. Otherwise, let's construct a new context ID object and add it to the collection. And last but not least, let's return the context resolver object. Depending on whether the tree is durable or not, we return either the tenant-specific context ID object or the original parent one. Also, we specified the payload object that holds the tenant ID property. This payload will be registered as per DI subtree request object. Finally, let's open up our app module file and apply this newly defined strategy. Note that we could have applied this elsewhere as well. We just picked app module as it seems to be the most suitable as we're applying everything globally in our application in our case, but you may want or need to do things differently in your system. With this in place, let's open up our terminals and use curl again and execute the HTTP request to the /users endpoint, this time passing in the x-tenant-id header of 1 just for our demo purpose. Now, let's switch to the other terminal window, and as we can see, even though we triggered this endpoint multiple times, the user service instance was created only once. More importantly, once per tenant. Fantastic. Also, we can see that the request context is now equal to the payload we specified in our custom context ID strategy. Now, just to verify and double check that everything works as it should, let's call this endpoint again, changing the xtenant ID header to be a different value. And voila, as we can see, what we did lets us construct separate DI trees per tenant. For example, we could have our application set up to have separate TypeORM or Mongoose connection per tenant, or any other multi-tenant situations you may need for your different tenants in your system. The sky's the limit from here. Now, before we wrap up this lesson, there's one feature we'd like to demonstrate as well. Let's open up our strategy file, and after inserting a new context ID to our tenants collection, let's add a timeout and invalidate, meaning let's remove that key after 3 seconds. Let's save our changes, open up our terminals, and use curl again. Wait at least 3 seconds and call the same endpoint again, passing the same tenant ID. Now let's switch to our other terminal window, and as we can see, after 3 seconds, our DI subtree got invalidated and recreated when we hit our application again. It worked. Great. So we covered quite a lot in this lesson. But in summary, although we just mocked out certain things like data source connections, etc. in our case, hopefully you can see with everything we've set up, we could have separate instances now per tenant, each doing different things if needed, whether it's separate connections, schemas per tenant, or dedicated repository data access classes that automatically assign tenant ID with where clauses, etc. Now that you know how to implement the basics of multi-tenants in your applications, the sky's the limit for your future Nest apps and their use cases.